So 7.1 is all about rational expressions and functions. And the first thing you have to realize about a rational expression is, first off, what it is. Rational means ratio. It's a big root of the word, so ratio means fraction. Now, it's the ratio of a polynomial divided by another polynomial. And that's basically it. Now, the main thing you want to do with a rational expression is always the first thing, factor. Now, as you get farther into these, when you start multiplying and dividing them, there's going to be more than one of these, and there's going to be a lot of factoring. So right now I got two factoring problems, the numerator and the denominator. Now the numerator you don't really have to do anything with, so, don't erase it though. It's just x plus 2. There's no factoring to go on with. At the bottom is difference of squares. X and x plus 2, and a minus 2. Remember, it has to be difference, it has to be subtraction in there. Now, I'm hoping what everyone sees when you're simplifying after you factor is you're going to cancel. But before you do that, actually, this is a step that a lot of people skip here, is our second step is you're going to find what's going to make your domain, all domain issues. What's going to make your denominator equal to 0? Because I'm hoping everyone remembers you can't divide by 0. Like, way to think about that is like, how could you cut up a pizza into 0 slices? That's when you do it and divide it, cut it up different ways. It just doesn't make any sense. So we want our denominator, x plus 2 and x minus 2. We don't want it to equal 0. So that means that x cannot equal negative 2 and positive 2. So you want to do that before you start canceling. So first factor, second set your denominator equal to 0, third cancel. Cancel anything that you can. So from here, the x plus 2's cancel out, and here's the big mistake people make is they'll just write, oh, it's x minus 2. No, it's 1 divided by x minus 2. So that's the first main thing. I'm going to kind of go through most of the notes here on one problem, and we'll come back and do another one, at least another example, so we can see everything. Now, everything, and this is our domain. So the question asks for domain. You can write x cannot equal negative 2 and 2, which implies everything else. So the other way you can write a domain would be everything but negative 2. Everything from negative infinity to negative 2, not including negative 2, and then from negative 2 to 2, not including either of those, and then also from 2 to infinity. So this is everything left of negative 2, this is everything between the two 2's, and this is everything to the right. I personally like just saying what x can equal. Implies everything else it can. Alright, now, not all of these are created equal. So, to do that, let's take a look at what this equation looks like graphically. So, before we do that, just recap what you do. So, first thing you do, factor. Factor to the top, factor to the bottom. If there's nothing to factor in one of them, leave it be. Second thing, find your domain. So this helps us find domain. You set your denominator equal to 0, just like you do when you're solving by factoring. Next set is cancel. Now, depending on what you're asked to do, this might be your final answer, 1 divided by x minus 2. But I might want to ask you things about vertical asymptotes and holes in the graph. I'm trying to remember what the book calls them. They're non-removable and removable discontinuities. I think they just really talk about vertical asymptotes in the book. We'll use the terminology hole in our class. So let's do this looking at our calculator. So in your calculator, in the y equals, I'm going to put an x plus 2 up top. Make sure you put parentheses around it. And on the bottom, we're going to have an x squared minus 4. Now, if you remember, the x plus 2 is what cancels out. Let me just make sure that I have that right. Yep, I do. Alright, so now when we look at the graph, I should expect to see something happening at both positive 2 and negative 2. Well, here at positive 2, I have this is called a vertical asymptote here. So we have vertical asymptote at 2. You see this crazy break in the graph? But at negative 2, I don't really see much. Let's go second graph and look at the table. So at 2, I see this error. Let's see what happens if I arrow up to get to negative 2. Well, I get an error at negative 2 as well. So what that's called is a hole in the graph. And if we were to zoom in right around negative 2, so I'm going to scroll over here to negative 2, just so that makes the zoom right in around it. Hit enter. And so here's negative 1, here's negative 2 right there. It's like, looks like it went way too far. Hold on. Let's go negative 3 to 3. Let's grab that. That might be good enough to see anyway. Oh, you can't see it yet though. You see over here at 2, that break? So anyway, if we zoom in really, really close, so here, let's make it go from negative 2.1 to negative 1.9, and that should probably be good enough. So here's negative 2 right here. Ah, there we see it. Little tiny hole in the graph. Now, how tiny is that hole? Well, it only happened exactly at 2. You shouldn't be able to see the hole in the graph. The calculator is doing it because it realizes when it tries to plot 2, it's supposed to have an error. But you really, really should not be able to see it. I know I had to zoom in pretty close to see it in the calculator, but that's kind of a figment of the calculator's imagination. So anyhow, that's basically the main part to this. So when we look back at the window, zoom standard again, the one that canceled out became a hole in the graph, and the one that did not is this vertical asymptote. So let's see what that means for our problem. So the rule for vertical asymptotes: do not cancel out. The ones that do are the holes. Now, so as far as this goes, the vertical asymptote, vertical A, which I'm write as V period A period, and that happens at the 2. This is the one that didn't cancel. X equals 2, and that's what I write. Vertical asymptote, X equals 2. And it's not really equal, it's more like vertical asymptote is X equals 2. And as far as any holes in the graph, X equals negative 2. And so if you wanted to make a graph, you can use your calculator. So if the question asks you to graph this, and you want to rely on it pretty heavily, so let's take a look at it again real quick. So here's the thing that people do when they use their calculator. They see this graph and they go, okay, well, something's happened here at positive 2. That makes sense. You draw a little dashed line here saying it's a vertical asymptote, and they just go, okay, well, it just does something like this and does something like that. And that, for the most part, is okay. Except here at negative 2, there should be a hole in the graph. So what you want to do is have an open hole showing there. So let me know that you know it's supposed to be there. People that just rely on the graph and don't know the algebra, they're going to miss this hole in their graph. Now, most of the stuff the book asks you to do is just matching, and if you get a calculator, well, fantastic. Matching is going to be pretty easy. But if you know quite a bit about it, you shouldn't have to worry about it too much. Alright, let's just try another one here. Let's go with something a little bit tougher. 2x squared minus 6x plus 4 over 4x squared plus 12x minus 16. Okay, so at first you go, okay, great, we got trinomials, there's numbers in front of the x squared, so I gotta do guess and check. Or I can do AC method. Now, usually when there's a number in front, we go with AC method. However, first rule in factoring is take out your GCFs. So if you get 2 out of the top, x squared minus 3x plus 2. And now I got a guess and check problem on top. Take 4 out of the bottom, x squared plus 3x minus 4. Okay, so let's see what we factor. So we have a 2, x and x, just leave the 2 out front, and then 2's got to be 2 and 1. So I want to get to negative 3, negative 2, negative 1. In the bottom, 4 out front, x and x, and I end up with a 4 and 1. 2 and 2 is not going to work. I want a positive 3, so plus 4 minus 1. Oop. Alright, so our domain. Do that first. X cannot equal. Now remember, 4 can't equal 0. So I don't really worry about that one. I worry about the x plus 4, which is the negative 4. X minus 1, if I add that over, I get a positive 1. X cannot equal these. That's my domain. So first was, again, factor. 2 set denominator equal to 0. And then 3 was cancel. Alright, well, the x minus 1's go away. And 2 and 4 can reduce down to a 2 on the bottom. And I can't really do anything else. So we end up with an x minus 2, and the parentheses out front are not necessary. Or 2 times x plus 4. And that's my simplified version. Now, if we're looking for vertical asymptotes, that's the one that doesn't cancel. In a whole, at x equals 1. So the one that went away, the one that like disappeared from the equation, that became the hole in my equation, is the hole in the graph. Now, if we want to graph this, we should know something's happening at negative 4. We should know that there's a vertical asymptote. And then it should know there's a hole at 1. Now I don't know the holes above or below. And if you wanted to be able to graph this by hand, the best way of doing it is like plotting points. Just pick some points to the left and right of this and see where they go. But most of the time, you're just going to go to the calculator. So you type in the calculator, see how it fits. Does it move down here? Does it go up here? Let's go through the whole process here really quick, and we'll get a good graph. So in your y equals, anytime you want to graph one of these, make sure that you put parentheses around the entire numerator and go with the original one. Do not go with your factored or your canceled. If you go with your canceled one, the overall graph will be good, but you will be missing the hole in the graph. It won't show up there no matter how hard you try, because you removed it. Alright, so on the bottom we get a 4x squared plus 12x minus 16. Alright, so overall, all I'm looking for is the shape of the graph. It's going up, and then it comes from the bottom, and at 1, I won't see it on my calculator, I won't see my graph, but there should be a hole on the graph. Alright, so to do that, your graph that you're making, so like up here, right? It came from the bottom, and we get a hole somewhere here at 1. Now, if you ever want to find the actual location, like the y value of this hole, you can always plug it into the canceled out version. So if I do that, I get a negative 1 over 2 times 5. So it should be at negative 1/10, which is just underneath the axis, but not by a whole lot. So you put it on the axis, it's kind of like what it looked like on the screen. No big deal one way or the other. But you gotta show that you know that there's a hole there, and it should be. The problem is it didn't draw with a hole. So you really should, here at 1, kind of stop. It doesn't go up like crazy, it kind of sticks around here. So it looks something like that. You do your best with it, but you should have vertical asymptote here, and you should have a hole here for sure. Overall, going up, and then coming from the bottom. That's basically it. So, recap. Factor the problems, set your denominator equal to 0, that will give you a domain, and again it can't equal 0. You cancel out whatever you can, and then whatever cancels is your hole, whatever doesn't is your vertical asymptote.